Hello everyone, welcome in a new video. In this video, we are going to solve a questions and related to basically related to the algorithm we discussed, the scheduling algorithm we discussed. And now we are going to solve the question that come in a gate examination. Okay. So the question is like we have a process. Okay. So we have a process like P1, P2 and P3. We have three processes. We have arrival time. P1 process come at 1, P2 at 1 and P3 at 2. After arrival time, we have a burst time for the CPU. The burst time is like 6, 4 and 1. Okay. After that, we have an IO operation. Okay. So in this question, what basically is we have a two burst times, and after completion of a one burst time, the process will perform IO operation. After that, we have an another burst time which the process perform and then terminate. Okay. So in this way, this question is basically what. So the IO operation for the P1 is 7, for the P2 is 2, and this is for 6, P3 for 6. Now the burst time for is 1, 9 and 5. Okay. So this is what a question is look like. What you have to do is you have to consider all the scenario, you have to consider the process scenario, and you have to execute this process. You have to execute this process in SRTF form. In which form? In SRTF form. You have to solve this process in SRTF. Now, what is the SRTF? Shortest remaining time first, in which you have to select that process. We have our smallest burst time. And if another process come who have a smallest burst time as compared to the current process, then what you have to do is you have to select that next process. Okay. So I hope you know about the SRTF. Okay. So now we have to solve it. And what is happening here in this question? After completion of a burst time, if let's say that P1 process complete the burst time, then P1 process goes for the IO operation. After completion of an IO operation, then P1 again do a burst. Okay. So in this way, this program is basically work. Okay. So we have to solve this question with SRTF scheduling algorithm, and we have to find out the average waiting time and turnaround time. These things are easy things, so we are not going to do that. We are going to simply find out the completion time. So first of all, for solving this question, what we have to need? We need a Gantt chart. Okay. So first thing that we need to solve this type of a question is a Gantt chart. Okay. So Gantt chart. This is a Gantt chart look like. Started from a 0. Now what we have to do is we have to select that process who have a smallest burst time. But at 0 arrival time, we have only one process, which is P1. So if we have one process available, then we have to select that process only. So P1 process get a CPU for only 1 unit of a time, because at 1, now what happen is P2 processes also come in a queue. So now we have a two process, P1 and P2. Okay. So and the burst time, is from 6 to 5. The remaining burst time is what? 5. Okay. 5. Why? Because 1 unit of a time P1 adds. Okay. Now we have a two processes. Whosoever have a smallest burst time will get the CPU. So among P1 and P2, P2 have a smallest burst time 4. So P2 will get a CPU for 1 unit of a time from 1 to 2. Why? Because at 2 we have one more process available, which is P3. Okay. So the burst time left for the P2 process is what? 3. Okay. Simple thing. What we do in SRTF, we are going to do the same thing. Okay. Forget about these IO and the remaining burst time. Forget about that. First of all, complete this thing with the SRTF. Okay. So after that, P2, now we have two arrival time, all the three process available. So whosoever smallest burst time will get the CPU. Okay. Whosoever have a smallest burst time will get the CPU. So P3 will get a CPU now, because P3 have a burst time 1. So P3 get a CPU and complete at 3, because it's have only 1 unit of time. Okay. After completion of a P3, now this is what the main thing is. After the completion of a P3, what we have to do, what P3 have to do, P3 have to perform the IO operation, because P3 is now completed. So when the process is completed, process go for an IO operation. Okay. So now what basically happen is P3 go for a I operation. What is the current value, correct arrival time, arrive at, what is the completion time of P3 when P3 go for I operation is what, 3. Now plus, now you have to write that value. You have to write a time where P3 perform an IO operation. So in this case, P3 takes 6 unit of time to perform an IO operation. P3 take 6 unit of time to perform an IO operation. So at 6 arrival time, P3 again come in a ready queue. Okay, this let's see this in this way, like P1, P2 and P3. We have a 3 processes, P1, P2 and P3. P3 completed, P3 goes for a IO operation. Okay, this is what our CPU is. P3 goes for IO operation. Now P2 and P1 process can get the CPU. P2 and P1 and P2 process can get the CPU, but P3 can't, because P3 is completed, it goes for an IO operation. After completion of an IO operation, in this case, for the P3, the completion time is what, 6 plus 3 is what, 9. 9. So at 9 arrival time, P3 again come in a ready queue. Okay, now P3 can get a CPU at arrival time of 9. Okay, so in this way we have to solve this question. Okay, so P3 now goes for an IO operation till 9, because 6 and 3 is what, 9. So at 9 arrival time, P3 again come in a ready queue. Okay. So if you are facing difficulty to solve this question by remembering, okay, which process come at that time, which process come at that time, then what you have to do, you have to make a ready queue chart basically. Okay. So you can write it like, okay, at arrival time 9, P3 process come. At arrival time 0, P1 process come. Okay. But we do a lot of practice of that thing, making a ready queue and these things. So we are not going to do in this way. We are simply remember that which process come next, and then we applied that thing. Okay. So P3 process come at 9 arrival time. Now we have only 2 processes available, P1 and P2. Now P2 have a smallest burst time, so P2 will get a CPU till 6. Means it completely executed, because there is no more process who have a smallest burst time as P2, because P1 burst time is what, 5, and arrival time at 6. There is no new process also available, so P2 process is now completed. P2 is completed. If a process completed, then what we have to do is process goes for an IO operation. So at arrival time 6, P2 goes for an IO operation. What is the completion time of a P2? 6 plus what is the IO operation time? IO operation time for the P2 process is 2. So 6 plus 2, which is 8. So at 8, so this is what, a 9. So at 8, P2 process come in a ready queue. So here you can see the thing that P2 process again come in a ready queue, but P3 process not, because P3 process arrival time is what, 9, and P2 is what, 8. Okay. Now after 6, one process available, which is P1, so it goes to 8. 6 to 8 means it only execute 2 unit. So the time left is what, 3. Time left is what, 3. Why? Because at 8, because it execute only 2 units, so 6 plus 2 is what, 8. At 8, what happened? P2 process again come in a ready queue. P2 process again come in a ready queue. So if a new process come, then we have to check that which process have a highest burst time. But here what's the catch is, P2 process burst time is completed, first burst time is completed. Now P2 use the second burst time, but P1 is not completed yet. So P1 is using the first burst time, let's say burst time 1 and burst time 2. Okay. But P2 uses the second burst time. Okay. Okay. So at 8, but here you can see that 3 and 9, 2 processes available, P1 and P2. P1 process is basically have a lowest burst time. So again, P1 process will get a CPU. P1 process will get a CPU, and P1 execute at 9 till 9. P1 execute till 9. Why execute till 9? Because at 9, what happened? P3 processes also come in a ready queue, and at 9 the burst time left is what, 2, because one unit we execute from 8 to 9. So the burst time left for the P1 is what, 2. But at 9 what happen is P3 process come in a ready queue. So now we have all the three processes available. Okay, so now P3 is also available. So we have three processes available, P1, P2 and P3. So P1, now we have to select that process who have a smallest burst time, because we are solving this question with SRTF. So P1 process have a smallest burst time, so we have to select that process. Now there is no new process available and never come in a queue. So we have now we can execute P1 completely from 9 to from 9 to 2. 9 to 2 means 11. So till 11, P1 is now completed and it can go for a IO operation. So P1 is completed. So P1 goes for IO operation. Completion time for P1 is what, 11, and the IO operation is what, 7. 11, 7 is 18. So till 18, P1 perform the IO operation. Okay. After that, what happen is we have two processes, P2 and P3. So whosoever have a smallest burst time will get the CPU, will get the CPU. So P3 process have a smallest burst time. So P3 will get a CPU. P3 will get a CPU till only 16, till only 16, because 11, because now because it have only execute 5 unit of a time, it completely execute 5. So 5 plus 11 is what, 16. So at 16, P3 is completely executed and no new process is come at 16 as well. So now we have to select the remaining process which is P2. Now from 16 to 18 we execute P2. Why I say this 16 to 18? Why not completely? Because at 18, P1 process again come in a ready queue. P1 process again come in a ready queue. So we have to check between these two processes who have a smallest burst time. So from 16 to 18, it used 2 burst times. So the burst time left for the P2 is what, 7. Okay. So now P1 and P2, two processes available. Smallest burst time process is what, P1. So P1 will get a CPU. 1 is less than 7. So P1 get a CPU till 18 to 19. P1 is completed. After that, only one process available, which is P2. P2 execute from 19 to 7, which is 26. So P2. Okay. So this is what a Gantt chart of this particular question is look like. Okay. So now you can easily find out the completion time as well. For the P2 is 26, P1 is 19, P2 is 18, P3 is 16. If you know about the completion time, okay, so for this question I solved this like completion time for the P1, P2 and P3. Completion time for this property, okay, so P2 is what, 26, P1 is what, 19 and P3 is what, 16. You can find out the waiting time and whatever the question basically asks you. Okay, so for this case you find out the average waiting time of the execution of a process, average waiting time. So you can find it like that, turnaround time minus the burst time. So whatever the values you get, three values, sum up all these three values, P1 plus P2 plus P3 divided by the number of process. We have 3 process. Whatever the answer is, that answer is basically a average waiting time. Okay, so you can solve it like that. Okay, so first of all you have to find out the TAT, completion time minus arrival time, completion time minus arrival time, and then waiting time, and then average waiting time. Okay, so these things you can done it by yourself. You do a lot of these things. Okay, the main motive to solve this type of a question is that how the Gantt chart is basically made. Okay, so you can do these things by yourself. Okay, comment down your answer, what's your answer is. Now we are moving towards the next question. Okay, so we have to do the same thing, but now in this question what basically come is like priority things. Okay, so we have a process is like P1, P2, P3, 3 processes again. Arrival time we have arrival time 0, 2 and 3. Now we have a priority. What we have a priority like 2, 3 and 1, and 1 is a highest priority. Okay, after that we have a burst time for the P1 is 1, 3 and 2, and IO operation time which is 5, 3, 3, and again the burst time which is 3, 1, 1. What you have to do is you have to do the same thing that what we do in this question. Okay, but in this question you are not going to find the average turnaround time or average waiting time things, what you have to do is, in this question you have to find out that the multi-programming, the question is looking like that, the multi-programming operating system users use primitive priority, means this multi-programming so many programs using the primitive priority scheduling algorithm, preemptive priority, preemptive priority. Remember this thing, priority process is of two types, non-preemptive and preemptive. It's a preemptive. Okay, means if highest priority process comes, then we have to select that process. Okay, preemptive thing means. Now you have to solve this question with preemptive thing, and you need to find out the finish time of a process. You have to find out the finish time of a process. Is find finish time of processes. And the options are like 11, 15, 9. Option B is like 11, 16, 10. Option C is like 10, 15 and 19. And option D is like 12, 17 and 11. So this is what a question is. And the sequence is like P1, P2 and P3. This is what a sequence is. So you have to find out these things. Means what, basically you have to find out that in this finishing time of the process means P2 completed what time? Here in this case P2 is completed at 26. So the completion time is what, 26. So you have to find these things. Okay, the completion time you basically need to find out. Now let's solve this question. So for solving this type of a question, what we need a Gantt chart. Okay, without Gantt chart you cannot solve this question. Okay, so okay, we have to make a Gantt chart. Okay, so this is a Gantt chart. Okay, at arrival time 0 now. Okay, so okay, wait. Okay, so now at arrival time 0, what the process, what basically the process available, we have only one process which is P1. So P1 will get a CPU. If only one process available in a queue, then we are not saying what type of scheduling algorithm it is, because only one process available. So P1 is selected. And the bus time is what, 1. So it only execute one. Completed. P1 is now completed. If a process completed, it goes for an IO operation. So here P1 goes for an IO operation. The completion time is what, 1 plus what's the IO operation time, which is in this case is 5. So in this case is what, 5. So 1 plus 5, which is equal to 6. So at 6 we this P1 process come again in a ready queue. Okay, now after this one, here you can see that the other process come at 2 arrival time. Okay, at 1 arrival time there is no process, Q2 come at 2 arrival time. So at 1 to 2 what happened, this, okay, so at 1 to 2 what happened, the CPU become idle. Why I say that a CPU become idle? Because at arrival time 2, then the new process available in a ready queue. So from, okay, so from 1 to 2 there is no new process. If there is no new process, it means what, there is no no usage of a CPU. So it means what, CPU become idle. So at arrival time 2, what basically happen is the CPU become idle from 1 to 2 because no process in a ready queue. After 2 we have process which is P2 available in a queue. So P2 come and execute till arrival time 3. Why? Because at 3 P3 process is also available, and the burst time left for the P2 is what, 2. Okay, so you have to be careful that when you execute a process you have to decrease the burst time as well. So the burst time left is what, 2. Okay, so after that P2 and P3, whosoever have a highest priority, now the priority thing, priority scheduling algorithm will come in a use. Whosoever have a highest priority get a CPU. So P3 have a highest priority, so P3 come and execute till the end because it's a highest priority, one is highest. So if other process come also, then it's not higher than this process, priority of that process is not higher than this, so this process completely execute. So P3 come and completely execute. The burst time is what, 2. So at P2 P3 execute from whole process. So from 3 to 2 means 5. Completion time of P5 process is P3 process is what? 5. P3 is now completed. Now it goes for an IO operation. If a process goes for an okay, so process goes for an IO operation. So we have to write that P3 process goes for an IO operation. Completion time is what? 5 plus what is a IO operation time, which is 3, which is 3. So 5 plus 3, which is equal to 8. So at 8, P3 process again come in a ready. So after that, we have only one process left, which is P2. So P2 will get a CPU till 6, because at 6, what happened is, now the bus time left is what? 1 till 6. Why? Because at 6, P1 process again come in a ready queue. Okay. So P1 again come in a queue. So we have two processes available at 6 arrival time, which is P1 of P1, because it's again bus time come, and the P2's bus time left is what? 1. So whosoever have a highest priority get a CPU. So among these two, 2 is what a highest. So P1 is the highest, have a highest priority. So P1 get a CPU. P1 get a CPU, and P1 get a CPU till 2 unit of a time. 2 unit of a time, and the bus time left is what? 1. Why 2 unit of a bus time? Because at 8, because 6 and 2 is what? 8. At 8 we have new processes available, which is P3. P3 is also available. Okay, so that's why P1 execute only 2 unit of a time. Now all these three processes available to execute. P1, P2 and P3, all these three processes are available to execute. So at 8 arrival time, we have to select that process who have a highest priority. So if P3 is in a queue, then P3 have a highest priority. So P3 will get a CPU. Bus time is what? 1. So P3 complete at 9. P3 complete at 9. Okay, so P3 is now completed. Two processes left, P1 and P2. P2 is not goes for IO operation till now as well. So you have to be careful that whatever the calculation you do, you are doing that correct or not. Okay, so P1 have a highest priority, 2 is greater than 3, and the less number highest priority. So P1 get a CPU, and the completion time for P1 is become 10, because at 1 unit of a time, when it execute 1 unit, it P1 is completed. So P1 completed, then P2 left. So P2 get a CPU from 10 to 11, because the bus time left is what? 1. So 10 to 11, and after that P2 goes for an IO operation. Now P2 goes for an IO operation. Completion time is what? 11. Bus time is IO operation time is what? 3. So 11 plus 3, so it become 14. So at 14, P2 come again in a queue. Okay, so now P1 is also completed, P3 is also completed. So there is no process available in a queue. If there is no process available in a queue, it means what? It means that CPU become idle. CPU become idle. From 11 to 14, what happen is CPU become idle. CPU are not using, not in a use. CPU become idle. Okay, and after that, what happen is P2 again come in a queue, and if P2 come in a queue, it execute, because only one process available, so it completely execute. So it completely execute. Bus time is what? 1. So from 14 to 15, P2 is now completed. Okay, so this is how what a Gantt chart is basically look like. Now you can see the options as well. What's the option is? Okay, so this is what a 9. Okay, not 19, it's comma 9. Okay, so now for the P2, completion time is, we have to write in a sequence P1, P2 and P3. Okay, we have to find the finished time of this process in this sequence. For the P1, completion time is 10, P2 completion time is 15, and P3 the completion time is 9. So option C match with this. So C is our correct answer. C is the correct answer. So I hope you understand these things, that how we are going to solve this question. Okay. So I hope it is clear to you that how the question in a gate point of view, that how the question is basically come. So in this way the question arises in a gate point of view. Okay. Sometimes what happen is, sometimes what basically the question is like, it removes some part of a process, some bus time of a process, and you have to calculate that thing. Okay. So we are solving that question as well. Okay. But the gate point of view, this way the question is basically arise. Okay. So I hope you understand these two questions, and we are solving more questions. So for that, what you have to do is you have to see the next video. these two questions in this video. Thank you for watching this video. Like the video and subscribe my channel.